Well, welcome. I'm getting ready to do a little looking under the microscope at one of the cells off of this bilipid membrane. Okay? And I'll show you what I'm talking about here. Okay, here's a spot where you can see, if you look right up in there, you're looking at the one bottom layer of, this is the bottom layer of the bilipid membrane. And that right there is the top layer. So you got the bottom layer right here, and the top layer right there. So, two layers. 1 and 2. And what I did was I harvested a while back, oh wow, it's been a while back, I harvested a cell off of one of these, and I'll show you that right now. Okay, actually the name of this video I did was harvesting a cell from a membrane of a dragon.
Okay, I took it right out of there, and I got in a video.
And that's where I took the cell out of.
But that's a lipid or a membrane off this dragon.
I can't remember which one. Anyway, I harvested a whole one. I brought it home, and that's what I'm showing here.
You think I'd be able to bust lava that easy?
In this video.
With a hammer?
Okay.
No, that's not.
So what Geology thinks this membrane is, or this stuff is they would think it would be eroded basalt, intrusive basalt, which can be any type of it could be diorite, or it could be granite. That's what intrusive basalt was. It's a magma under the surface that can be like diorite or granite or something like that in a molten form. That's what intrusive basalt is, and that is what they would say this is. But it's eroded intrusive basalt. Only problem with that is this is silicon dioxide. This is sand, compressed sand. Intrusive basalt cannot transition into silicon dioxide. It's absolutely impossible. For them to think that this is eroded basalt is insanity, and it can't even happen according to their chemistry and their science, okay? It can't transition. Intrusive basalt can't transition into silicon dioxide, what you're seeing in front of you, okay? So, what I did was I'm getting ready, and I'm going to take that cell that I got down to this end that I harvested off this bilipid membrane, and we're going to look at it underneath the microscope. It's silicon dioxide. It smashes really easy. It's not that hard really, and it's sand. So explain this to me. How come this didn't transition into a layer of sand like this did, or this in between the two bilipid layers? How come this sand didn't transition into this? How come how come the sand got so smart to do this, but the rest of the sand stayed stupid? Huh? Explain that to me. And it's not eroded basalt, intrusive basalt. That's an impossibility. So if you're a geologist or somebody that thinks you know Geology 101, you need to go back to school and relearn. Because it's an impossibility. It can't transition into silicon dioxide. So we're going to take a look at this under the microscope, and I'm going to show you that it's not an eroded intrusive basalt. So that means that they're wrong. That means their theory's wrong. That means, it's biology. Thank you. Alright, so this is the cell out of that membrane that I drilled out and brought home. Okay, I got it laying outside right now. Normally we would be laying this way, but it's cracked and broke open, so it's not going to stay together. So it looks like that, and it's broke apart. And so what I'm going to do is I'm going to break it open again with a hammer, and then we're going to see it's made out. This is just really compacted silicon dioxide. There's no way that this membrane would have been eroded basalt, intrusive basalt. That is what they would try to say it is, but it's not. It's sand, silicon dioxide. So why did this transition into two layers of the membrane, yet the sand and everything around it and the stuff below it and the stuff in between the two layers didn't turn into this? You see what I'm saying? And why would sand turn into that? Why would silicon dioxide turn into two layers of looking like a membrane? And how would the sand know to be that smart to separate into two layers and look like a membrane? How would sand know to do that? Please explain that to me, because I don't understand it. I'd like to know how sand was able to form into a bilipid membrane. So we're going to look at this under a microscope, and I will show you. It's just, all it is sand. It's silicon dioxide. It's not eroded intrusive basalt, which can be, diorite or granite or anything like that. This is not even in that category. This is sand. Silicon dioxide. And we're going to bust it open and we'll look inside. I mean, on the outside, it really comes off, you know, like sand. And the deeper you go into it, the harder it is. But it's still sand. So, or silicon dioxide. All right. And this is what the side view looks like on one of these, what they're shaped like. This is what an individual cell looks like from the side. That's what they're shaped like, each one. Alright, so we're going to bust one of these open so I can get inside it. There, we got enough pieces. Wow, that's killer looking how it just got really compacted like that. Really cool. This is going to be fun to look at. So, there, we're going to look inside this cell. This membrane cell with a microscope now. Alright, I want to show you how soft this is too. It looks really super hard, but it's really crumbly. Watch how easy this smash into sand. See that? So it's not super hard, okay? It's sand. That's what that is. See? It's not like granite or diorite. It's really actually kind of soft. Okay? Alright, here we are. I got that all broke open, that cell. And you can see on the inside here, it looks like, you know, if you didn't know better, you'd say, man, it even looks like granite. But you'll see it's, I mean, I can break it off with my fingers. It's really soft. Not as hard as you think. It's sandstone. So we're going to look at it in the microscope, and I'm going to go ahead and check it for catalase. I don't expect to find any, but I'm going to put a little hydrogen peroxide and see if it has a reaction, a catalase reaction. But we're going to look at it underneath the microscope, and then we'll get it up on there. So just give me a second here. And we'll, yeah, get this thing plugged in. Okay, let me see. Alright. Now we're going to be going up to there. Turn off these lights. Turn off this light. Alright, so let's just take a look at the end of it here. Old steel there. Alright. That, you see all the silicates there? That's silicon dioxide. That's sand. See all the white, grayish looking stuff, all the crystally? And you see red up here in the corner, the right hand corner. This is sand. Let me get another piece here. A little better here to look at. It won't move around as much. There you go. See all the silicates in it? Now I believe it's these silicates, or silica, or whatever you want to call it, or what's transitioning in the membrane. Grab another chunk here, a big chunk, that big chunk. Same stuff. Okay. Now I'm going to put some hydrogen peroxide on here. Let's see if I can get a reaction. I might not, it's hard to... Now I'm not expecting to see anything because of it being sand. And it should not be in here. I'm getting reaction. Down the right hand lower corner. Look at that. Right almost in the center of the crosshairs, right below that biggest piece. We're getting reaction. Now think about this. Catalase should be all over the earth if the earth is created out of carcasses. You understand? If they're the size of what we're seeing, then the whole earth, imagine the enzyme catalase and how much of it if the earth is covered in carcasses. Right? So let me put some more on. Yeah, get some on there. Oh, come on. Okay, let's take a look at this now. Yeah, look at the reaction. Lower right hand corner. Oh my gosh. Look at the reaction we're getting right here in the right hand corner. And see, I wouldn't be looking for any membranes because this is a membrane. So I wouldn't be looking for the membrane around something, you understand? Because this whole thing is a membrane that's the size of a highway sitting on it. So if this should actually have catalase in it because it is a membrane. It is reacting everywhere. Look up in the upper right hand corner up here. Right there. Look at that. It's all over the place. And this is on the inside. I broke it open with a hammer so there's no cross-contamination. You see me break it open with a hammer. Look at it right there in the center. Right about the crosshairs. Just above the crosshairs. Look at all the reaction. To the right, upper corner. So, you know, I wouldn't be finding a small blood vessel in this because it's so big, the membrane, it's, like I said, the highway's going over it, okay? So this, we should be, if this was just sand, we would not be getting a reaction. Because sand cannot have a catalase reaction. Okay? This is not sand. This is biology. And that's why we're getting a catalase reaction. But it's on a scale that's off the chart. Look at that, right in the center, just above the crosshairs to the left. Look at it just boiling there. Okay. So there you go. There's what we were doing. And we're looking at these chunks. In fact, this is the piece I put the hydrogen peroxide on. I could put on another piece, and we'll take a look at this piece real quick. I'll put some more hydrogen peroxide on it. And then we'll look at it real quick back up here. I may have to wet it again. Look at the reaction we're getting all over the place. Look at that! Holy cow! Okay, so there you go. This is biological because I'm inside of this, what they think could be eroded basalt, and it should not have catalase reaction if it's eroded basalt inside of this, and we're getting a catalase reaction. So that membrane, or this what they want to call just sand, this bilipid membrane, upper layer and lower level, this is 100% biological. We just proved it right here. So, bam! That just happened. Blows a hole right in their geological theory. A big one.